Namaste and welcome to Pavitra Laptop Care. Before we begin the video, please note that as this course is still in its early stages, this video is solely intended for students at the beginner level. As the course progresses, videos for advanced levels will be posted on this channel soon. So, please stay tuned to watch all of them.
Welcome to Pavitra Laptop Care. Today I am going to tell some important points to our students in V-in section. See, in case of V-in section problem has come, so what we have to do, what are the basic steps we have to take. See, in some cases, some V-in sections will be very easy to attend the cases, okay? But in some cases, it will be very difficult. So one case here it has come. See, here the USB port has completely got rust. So due to this particular board has problem. It's completely dead. Okay. So I will show to my students step by step what we have to check in a particular case. I'm not giving 100% assurance to for solution of this particular case. Okay. Just I wanted to tell them what will be the mistakes. Okay, let's see. This motherboard part number is 6050A23266001. Okay, I will show you. 6050A2326601. Okay, this one laptop model number is HP PROBOOK 6450B. Okay, this is dead because of, see the condition of USB. It's completely got rust. It's completely rusted one. Okay. But all the other parts are very good. It's looking very nice board. Anyway, we have schematic for this, so let me check step by step, one by one. Here I'm going to connect to the DC machine. So what will be the result? Let me check. See, I connected DC. Here it's showing 0.007. Okay, 0.007 or 6. It means its amp not taking much. So it means V-in section is not coming to the particular motherboard. We have schematic. So as per this is a DC jack connection. Here is the DC jack. It's onboard DC jack. I'll show you. See, here this is the DC jack, this is the onboard DC jack. Okay, this is the L1. So from here we need to check the voltage one by one. So now we need to check the CLR. So just a minute. So this is the L1 coil, first MOSFET, second MOSFET. After that R526 is the CLR point. Okay, R526. First I will check the 526 CLR. Here it is. okay, or 526. Here is the CLR. So here voltage I will check. See, I will connect to the DC machine. Load is 0.006. okay. Now I will check CLR voltage. There is no voltage in CLR. Okay, I will check in DC jack. This is the pin ID. See, 1.4 volts. It's ID pin. And this is a V in section. See, 19.52 volts. Here, DC jack adapter voltage is coming here. 19.52. Next step, you need to check. See, here there is no voltage, and here coil L1 coil is there, that we found actually. Yes, this is the one. See, here is the coil. See, a coil voltage is there, 19.52. okay. Next it has gone to where Q533. okay, Q533. See, VIN is here, but MOSFETs are not there nearby this, so we need to search some other places. Q533. Yes, it is here. See, I'll show you. Q533. Q533. Okay. Here, in this MOSFET source we need to check 1, 2, 3. This is the source. See, source is getting 19.53 volts. Okay. What about drain? See, here drain voltage unavailable. Okay, it's not available here. So I'll check gate voltage. See the gate voltage, 15.73. 15.73. Okay, gate voltage is 15.73. But see, as per the circuit, I mean here voltage divider is there. Okay, second one, resistor pin number 1 should be ground. Okay, it should be ground, but here it's not happening. So because of that, we are getting more than 15 volts in the gate. This is the common point. Okay, some people in this case See, clearly I will tell you, in this particular case they will get stuck and they will remove this one and they will make it short. Okay, if they will make it short, definitely you are supposed to get, they will get the voltage, but we need to understand for what reason here it's not ground. Okay, let me check this Q34, then I'll come to the point. Now Q34, connected to DC jack. Q33, Q34, yes. See here I got Q34. Okay, Q34, and this is the one Q34. Here this both gate, it's a dual MOSFET, n channel dual MOSFET. See the circuit Q34, it's a gate, it's pin number 2 and pin number 5, both are n channel dual MOSFET. Okay, 6 leg dual MOSFET, I see this one. Now the common mistake a technician will do is they will make a short, make a jumper from here to here, pin number 1 and pin number 4, or they will remove this one and directly they will give the ground connection to this particular resistor. Okay, that we should not do, because of some voltage issue only this particular protection will be there, otherwise this protection should not happen. Okay, for what reason it has disconnected here, so that we need to check. Okay, there will be some point will be there. Okay, now so let me check this gate voltage and this pin number 1 and 4, what it will be. It's a Q34, so ground, pin number 1. See, pin number 1 is 2 volts. What is the pin number 1? Is a source. Okay, next pin number 2. .3 volts. Pin number 2. 3.3 volts. Okay, pin number 5 I will check, that also gate. See, other gate giving beep. Okay, here adapter enable is giving beep. Okay, VCC1 4-3 is available, 3 volts, but other gate is having ground, so it's a digital ground or direct ground, that we need to check. Okay, so how to check? Any idea? We need to disconnect the power supply. I disconnected. See, now I will check the gate. See, there is no ground at all. There is no ground. Okay, again I am going to connect the DC jack. Now I'll check. See the beep, it's called digital beep. Okay, it means it's protecting the motherboard, that is the meaning actually. Okay, so anyway, let me check further. Now according to the schematic, DC jack voltages are there. See, here VADP in is available, VADP after this L1 voltage is available, and VADP is also available, up to this particular MOSFET Q533. Okay, 1 2 3 pin number it's available. Pin number 4 has voltage divider circuit here, but it's not completed. We can't tell it's a voltage divider because until unless this goes to ground. Okay, this is the main point you have to think. Okay, see here what kind of protection is there here. Here they have used one dual channel 6-leg MOSFET. Okay, 6-leg MOSFET dual channel. One gate they have given VCC1 4-3 and other gate they have given adapter enable. Okay, these all are logic gates. Using the logic gates this particular IC will work. See, condition is fulfilled, then only adapter enable should come, and then this source to drain, I mean drain to source supply will goes to ground. Okay, this source is ground and this source is connected again to drain of second MOSFET, and second MOSFET drain to source will goes once the enable comes to the gate 2. Okay, this is the logic actually. Once again I'll repeat, this voltage regulator is not fulfilled because of this second, because until unless second resistor goes to the ground we should not consider it as a voltage divider. Okay, for fulfill the voltage divider they have given dual MOSFET, 6-leg dual MOSFET. So using gate 1 they have given VCC1 4-3 as a gate voltage, and the second gate voltage adapter enable. Okay, adapter enable. Here what we checked, it's a VCC1 4-3 has come. It's a 3.3 voltage, and here adapter enable giving digital ground. You know why I'm saying it's a digital ground? It's actually giving beep only we connect to the power supply. Okay, only when we connect to the power supply then only adapter enable is giving ground. This also ground, but this one is not becoming ground because here voltage should come. This is N channel MOSFET. This both are N channel MOSFET. When gate voltage has come, then only drain to source supply goes. Okay, this is the logic of this particular MOSFET. See, according to this MOSFET, so once gate voltage is fulfilled, then only this source to drain voltage will pass. Okay, source to drain. If see here drain voltage is not there, then what we have to check? That is the major question here. Okay, see, in this condition definitely some people will short this one to ground. Okay, they will check this voltage will come or not. Actually see, this one is because of protection, as I told. If you are advanced level student, so definitely you people will think what is adapter enable. Okay, then you come to know where will be the exact problem. Okay, like this we have to think, but I'm not giving 100% solution for this board, but anyway thinking of level I'm telling using this video to my students. Okay, see this adapter, this one no issues, already we are getting 3.3 volts, but here adapter enable is there. That one we need to copy, you need to search. Where it has gone, see, same one going to the, I mean it's pin number 75 of IO. See, sometimes what will happen in some condition the particular schematic will be the wrong one. Here adapter enable is going to the IO, but really I don't know it's going or coming. Anyway, any other circuit here? See, here it's a black diagram of particular schematic. Okay, they clearly mentioned limit signals from adapter. See, from adapter some signals should come to the OCP level, then these signals will start. Adapter enable OCP OC hash adapter PS0 and 1. Okay, this is overcurrent protection circuit. And then charger BQIC is connected to the overcurrent protection circuit, and from this what is it, charging IC requirement is charging controller 3, adapter present, AC and charging. See, these signals are coming to the going to the charging IC, then BQIC will produce VBDC. Okay, that one goes to selector discrete. So, and here see VBAT, battery, main battery and traveling battery. Here two batteries are connected. From here selector, it's going to what is it as a name of VBATR to all circuits. Okay, all circuits. See, 3.5 volts section, RAM 1.8 volts RAM. It's actually DDR2. Okay, it's not 3. 1.5 is a DDR3. Okay, this one SLPS4, what is that, 1.5 volts, VTT, VGFX, IO power. This circuit has to fulfill, then only we will it will goes to particular section. It goes to particular sections. Okay, this is the basic concept. Here one clue I got from charging IC going to the OCP section. Then OCP section will generate adapter enable. Okay, but as per the schematic, so that OCP adapter enable is going to this particular MOSFET, dual channel MOSFET, and as well as IO. Okay, see, pin number 75. This is the logic. By patience we have to check one by one. Please don't do in hurry-burry. First you spend time to thinking of these things, then only easily you can solve the problem. Okay, our students, please note down once again, have patience. That is a very, very important tool to detect the problem. Okay, anyway, so see, this adapter enable. Okay, then now in this condition, again what we have to check. See, here MOSFET output is not coming. If there is no MOSFET output, we can't check further CLR or anything. And see, this voltage also unavailable, then we should not go to other sections. Then what are the sections is enabled at present in this condition, and how to solve this problem? See, basically I will tell you, even I also don't know particular board what is the condition. Okay, see, logically I will tell you, this is a DC jack, we are getting DC jack voltage is here till L1, that become as plus VADP. Generally I'll guess and I'll tell you, see, up to here we are getting, but here there is no name. After this MOSFET only we are getting this particular name, right? So first we need to copy this and we need to check what is the path of this particular name voltage. Here we are getting it's 19.5 volts. Okay, not this one. Next, see, here on VADP is going to op amp. See, this is called op amp. Here comparison will be there. See, here if supply comes here, see these two resistor, it's a voltage divider resistor. Okay, here 19.5 volts are there, and after becoming this, some particular voltage making here, and here V reference also will be there. It will be constant 2 volts. See, here only the reference they given. Pin number 2 having 2 volts, and pin number 3 divider of this voltage regulators. Okay, sorry, voltage divider. Then it gives some output in pin number 1. The name is AC adapter present. Let us check the pin number 1 of UA. See here UA and UB. Actually UA is not separate IC. UA and somewhere it will be B also. That also we need to check. Both will be single MOSFET or IC. It's a comparator. See UCA. And here somewhere will be there UCB. See UCB. Here also one separators are there. Adapter present. See here UCB is giving adapter present and UCA is giving AC adapter presence. So let us check this comparator, what it functioning and what are the voltage we are getting in this. Okay, let me check U6 in this board. U10, here I got U6. See, this is U6. Okay, here what are the voltage we are getting? Let me check. Pin number 3 and 2. Okay, 1 should be output and 3 and 2. If 3 we are getting, then here VADP is generating. It's good here. Okay, so what it's generating, that we need to check. Pin number 1. See, pin number 1 is 3.2 volts. Okay, it means here pin number 1, AC adapter present. AC adapter present signal we are getting, I mean voltage we are getting. Let's check pin number 2. See, pin number 2 is the reference voltage 2 exactly we are getting. So, pin number 2. See, 2 volts. As per the schematic, it's 2 volts. Okay. P reference. Pin number 1 should be the voltage divider volts, P out. Okay. Number 3. Pin number 3. See, 2.2 volts. It's more than reference volts. That's the reason we are getting output. I'll explain you once again. This comp app, what it will do, it will compare positive and negative. See, if positive should be greater than negative volts. Here pin number 2 having it's a 2 volts and pin number 3 having 2.2 volts. That's the reason we are getting output as 3.2 volts. That output is AC present, AC adapter present. Okay. If AC adapter present is there, then also there is a production adapter enable is ground, but I don't know what the reason. Okay, anyway, Let me check one more. What is it? U6B. We will check for the condition of U6B. We already checked pin number 1, 2, 3. Okay, here 4 is the ground. So again 5, 6 and 7 is the output. 8 is the input of this VCC op amp. Okay, here pin number 5 I will check. Pin number 5. Pin number 5. See, 2 volts. Pin number 5 is 2 volts. What is that? Pin number 5. Pin number 5 is 2 volts. And what about pin number 6? Pin number 5 and 6. Pin number 6 having beep here means it's getting short. Pin number 6 is a negative. But see here, that major difference is pin number 2 we got 2 volts V reference, right? But here pin number 6 having short, so 0 volts we are getting. Once again I'll check pin number 6. Pin number 4, 5, 6. 4, 5, 6. 6 is 2 volts. See, 6 is 6 is 2 volts. Pin number 5, 4, 5. Just a minute. We are unable to get pin number 5 here, so we are getting pin number 6. See, we are getting reference voltage, but pin number 4 unable to get. Sorry, 5, pin number 5. This one is a positive voltage of this comparator U6B. Okay, here we should get once we get the voltage from here. Okay, so obviously we won't get this voltage because AC is not passing through the MOSFET drain. Okay, that is the reason we are unable to get. Other than this, what will be the reason? See, here using VADP, okay, we got here one op amp. Okay, op amp here, what it will do, it will compare two voltages and gives output. Okay, here number 2 is 2 volts and number 3 is 2 volts. That's the reason we got higher output here. Pin number 1 we got 3.3 volts, but here there will be no voltages. See, pin number 7 I will check. Pin number 7, 4, 5, 6, 7. Pin number 7 is negative. Obviously it's negative because we are not getting inputs. Okay, let us check some other section. This is the one section we found, and we got the output of AC adapter present, but we won't get adapter present because here the main voltage is not passing from this particular MOSFET to, source to drain. Okay, now let us search. Here we searched. Here is this is a different one. This is also different. Yeah, see here. One more diode D507. One diode we have to check here. That diode, what is the result it giving? See, this diode VADP debug. It's giving the output of debug. Okay. Then it's going to pin number 3 of diode 506. Then bat A, bat B is a selection of battery. Here VADP, see D507. Let us check D507. D4, D5. What's that diode number? D507. (503). See, here is a diode 507. Okay, positive, negative here it's given. So anyway, voltage for this we will check. We will check D507. See, one side is giving 19.52 volts, other side 18.82. It's common because of diode. Some loss will get around 0.7 volts loss will be there. That's the reason we are getting it's 18.8. Okay, this may be good. Anyway, so next where we have to check. Here VADP debug we are getting 18.8 volts. Next section, see V bias. What voltage it's giving here? Resistor we can't search because resistor number not given. So that's the reason we'll go to next section. It's what is that? D23. If we find the D23, then we can easily search the resistors, these two resistors. Okay, we will check D23 then. D23. D23. D17, D21, D24, yes, D23. See here, so D23. Okay, we will check the voltage. See, I am teaching to basic level students. They don't know anything about electronics things. Okay, for them I am teaching. For them I will teach. I am teaching. This is the one, right? One side not there. What is the voltage? D23. Okay. D23, one side. See, one side we are getting only 1 volts and other side no voltage. Okay. Here in pin number 1, that pin number 1 we are not getting any voltage because of limit signal 100. See, pin number 2 we are getting only 1 volts. It means just I am thinking VADP in this section it's not available. You know why? Here in pin number 2 at least some voltage should be there. It's a voltage divider, so we will check once again. Just a minute. By continuity I will check the resistor, so then we can decide which resistor having V plus, voltage of this one VADP. Here pin number 2 is connected to 33K. See, using continuity I am checking here. One resistor is connected here, that one having 33K. Okay, 33K we got, 33K. Next to that 68K, it's a R221 we should get. This one